Today we are going to do the planning question of May-June 2022, variant 41. This is question number 3 in the paper, which is related to the planning. And I'm just reading the question. A student has three colorless organic liquids, and the liquids are W, X, and Y. Now, these are the further steps, the further lines are giving you the information about the compound X, Y, and Z. So they're stating, number one, that the one of them is an alkene, right? Another one is an alcohol, and out of these three, one is your carboxylic acid. So your compound W, X, and Y, either it's an alkene or it's an alcohol or it's a carboxylic acid. But the student does not know which liquid is which. He doesn't know whether X is an alkene, Y is an alkene, or W is an alkene, or whether which one of these is an alcohol or which one of these is carboxylic acid. Now, what the examiner asking us to do is, now you have to describe a series of tests. So you're supposed to give the series of the test in order to determine which liquid is W, X and Y out of W, X and Y, which is an alkene, which one is an alkene, which one is an alcohol, and which one is a carboxylic acid. So you are supposed to give the test and you are supposed to give an observation to identify that W, X, and Y out of these three, which is an alkene, which is an alcohol, and which one is carboxylic acid. Now, further, what detail are given that each liquid must be identified and its positive test need to be given. Now, further, what you have been provided with, number one, the separate sample of liquid W, X, and Y. You are given the different samples as W, as X, and as Y. Apart from that, you have been given the chemical that is your acidified potassium permanganate. This acidified potassium permanganate, as we already know, it is basically our oxidizing agent. It's a lab oxidizing agent. Okay, so this is a chemical which is going to help us to identify any reducing agent, or if a substance is going to undergo any oxidation. The second chemical is basically your bromine. It's an aqueous bromine. Now we already, when we have done the chemical test for an alkene, we have seen that the alkenes decolorizes the reddish brown bromine into a colorless solution. So basically, the bromine will be an identification test, will be a chemical to identify the alkenes. And lastly, the third chemical which they have given you is solid carbonate. So carbonate, whenever reacts with an acid, they will be giving you a carbon dioxide, an effervescence of carbon dioxide. So this is an identification for an acid. So we have the three chemicals here. Number one, we have acidified aqueous potassium permanganate, which is a lab oxidizing agent, which is going to tell us that which substance is being oxidized, right? The second one is an aqueous bromine, which is used as a chemical to identify the alkenes, which have a carbon-carbon double bond. And the third chemical is calcium carbonate, which will help us to identify the carboxylic acid by giving out the effervescence of carbon dioxide. Apart from this, all the apparatus they are available for us, whatever are they present in a school lab. Now, after this, in your answer, now what are we supposed to write in our answer? We have to very clearly, they're asking us that these four things should be included in your answer. Number one, which should be included in our answer is there should be a test, the positive test, if you're going to identify W, X, and Y as an alkene, alcohol, or carboxylic acid. That's point number one. Number two, then the apparatus which you're going to use for these tests, whether you're going to use test tubes or delivery tube or any other stuff. If you want to heat it, then what apparatus, directly heating, indirectly heating, through water bath, whatever, you're supposed to give all those apparatus. Number three, how the results of the test are going to identify whether it's W, X, or Y. So you need to tell that which this particular test is going to give a positive test by giving carbon dioxide or whatever effervescence. So this is W has been proven as the carboxylic acid, right? So you have to give the positive test and the other two are giving negative test. So they are not being identified as a carbonate, something like this. Okay. Then apart from this, very importantly, you are going to you have to give the steps or the pointers to ensure your own safety. So you have to give the pointers for the risk assessment as well. So if there is a chemical which is toxic, or if the chemical is flammable, then you have to also give the pointers like the flammable substances need not they need not to be kept near the naked flame, or you need to heat them indirectly through water bath, or if they are toxic, then you better wear the goggles or something like that. So these pointers, in order to avoid any safety risk, you have to give the pointers, the precautions. All right, so let's start with our solving of this planning question. Okay, so we are going to plan it in this way. The space, this whatever the space is given to you. So I have 5 columns here. In the first column, I have mentioned the test for the alkenes. The second point is a test for the substance which will get oxidized. I'm using an oxidizing agent. And the third is I'm adding the calcium carbonate. I'm just reading it out. So I have taken what I've taken is what is going to be my test. I'll take the sample of WXY in the separate test tubes, and then I'll be adding aqueous bromine to it, right, in each test tube. So the test tube which is going to be the test tube which will decolorize. So here with depending on my observations, right? So whether it's X with W or Y, so depending on my observations, the substance which is going to decolorize my reddish brown bromine will be actually my alkene. So let's suppose if this substance W is basically decolorizing it, if it is decolorizing my, if this is decolorizing the reddish brown bromine, if it is decolorizing reddish brown bromine, whereas definitely because we have one alkene only, so definitely there will be no observation seen, no change seen will with the X, and similarly there will be no change will be seen with the Y. So the substance which is going to show the decolorization will be actually an alkene. So W is showing the decolorization of reddish brown bromine. So I'll say that W is an alkene. W is an alkene, right? Now the second test I have the next 3 test tubes with me, and with all the 3 test tubes I'm performing the same test. I'm adding astaphite potassium dichromate to it in all the test tubes. So whichever test tube is actually going to decolorize the color of potassium permanganate, potassium magnate 7. Now, let's suppose there is no change being observed because the W has already been identified as an alkene. So definitely it will not be affected by acidified potassium permanganate or acidified aqueous potassium magnate 7. Now, maybe with X, it will show a change in color, and the change in color will be the purple substance, the purple color substance, the purple oxidizing agent, or purple acidified potassium magnate 7 will get decolorized. The purple acidified potassium magnate 7 will get decolorized. Say, okay. So now if this is the test, which is a positive test, which is showing that this substance is an alcohol. So alcohol basically get oxidized by an oxidizing agent to give you carboxylic acid. So with this test, this is a positive test with the carboxylic acid. So this is basically a positive test for an alcohol, because alcohol, out of these three alkenes, alcohol and carboxylic acid, it's the alcohol only which will be giving this positive test. So we identify the X as an alcohol, right? Because alcohol will only get oxidized and by using an oxidizing agent, and it will be converted to carboxylic acid. Neither alkene will oxidize nor carboxylic acid will oxidize. So we have, from the observation, we concluded that X is an alcohol. Coming to the third part, now again, I have the same chemical added to all the three samples of WXY, and this time I'm adding calcium carbonate to all the three test tubes. So again, I will observe no changes here, no changes observed here, right? Because I have already observed here, because I've already identified this chemical as an alkene. Similarly, no changes will be observed here. The reason is because this X has been identified as an alcohol. Now, Y will be showing the changes, and in Y, we will be seeing the fizzing or we will be seeing the effervescence. Both the options are correct. We'll be seeing either the fizzing or we'll be observing the effervescence. Now, these effervescence is an indication that the carbon dioxide is produced. Now, if you further want to confirm it, then what you can do is you pass this gas through lime water, gas through lime water. And what will happen? The lime water will turn chalky white. So that this confirms the presence of confirms the presence of your acid. So because the acids, they when they react with the metal carbonates, so they give you the carbon dioxide gas. So here what we observe, from the observation, what we conclude is that our Y is your carboxylic acid. So these are carboxylic acid. So these are the positive tests on the basis of the observation, on the basis of these observation. This is observation which is a positive observation for an alkene. This is another observation with the second chemical that proves that this is an alcohol. It's a positive test for an alcohol. The third observation with the metal carbonate, it giving carbon dioxide, again proves that it's a carboxylic acid. So this is how we are able to prove that W is an alkene, X is an alcohol, and Y is going to be carboxylic acid. Now coming to the next part of it. The next part, examiner asks us to give you the risk assessment, right? So we'll look into it. I'll go through that particular point, read it again, and then come back to the solution. So we have already seen this particular part. I've explained you how to describe what tests are going to prove that which one is an alkene, which is an alcohol, and which one is a carboxylic acid. Now, the apparatus also I have mentioned during while specifying that the test that I'm going to take 3 test tubes and I'm going to put the sample of X and Y in the 3 test tubes, right? Now, in order to have a fair test, have the same amount of all the 3 chemicals, W, X, and Y, so that also you can add on to the test. Apart from that, now comes the last part, the safety risk. So we already know that these the W, X, and Y are basically what? That's an alkene, and X was our alcohol, and the Y was confirmed as a carboxylic acid. Now we need to do the risk assessment. We need to have certain precautions in order to avoid any risk. So we know that the organic compounds are basically all the organic compounds, whether they are alkenes or they are alcohol or carboxylic acid, they are highly flammable. They are flammable. So because they are flammable, so they should not be kept close to the naked flame. Say so, avoid keeping them near the naked flame. That's number one precaution. right? Now comes the second precaution. This is the first one. Coming to the second precaution. The second precaution is basically the some of these chemicals are toxic in nature, right? Some organic compounds are, again, some of them are toxic in nature. So the substance which are toxic in nature, and for those we need to wear the gloves. We need to wear the gloves, and need to wear the goggles as well. So goggles as well. So these are basically the precautions we will take in order to avoid any risk. So this is again going to be your 2 marks out of how many marks? How many mark question was this? So this was basically your 8 mark question. So the 6 marks are for the identification of the 1 mark for the test, 1 mark for the observation for each W, X, and Y. And the remaining 2 marks are for the risk assessment, the kind of precautions you will take in order to avoid any risk. So you can write it down in this form, the way I have depicted, in the form of a column, or you can write it down in these lines. It's up to you how you explain, but you need to include all the points which I have mentioned in the table.